Okay, this lesson is on solving equations with radicals. We're going to start with a very simple equation. We're going to start with this. Square root x equals 3. To solve an equation that has a radical in it, I square both sides. I can square one side of the equation as long as I square it with the other. So I'm going to rewrite this, and squaring both sides like that. The square root and the square here cancel each other out, and that will just leave you with x in there. And on the right side, 3 squared is 9. Now, it's always a good idea to check the solutions to these. Whenever you're squaring both sides of an equation, you can get what are called extraneous solutions. In other words, numbers that really aren't solutions. So you should always check your results here. Plugging 9 in to the original equation, is the square root of 9 equal to 3? And that answer is yes, so it works. And so our solution is 9. 9. Square root 5x plus 1 equals 4. Okay, just like the last example, to solve for x, I'm going to square both sides of the equation. Just like this. Squaring this side, the square root and the square cancel away, and that leaves me with just a 5x plus 1 under the radical sign. That equals 16. Okay, now I'm going to solve for x here by moving the 1 over. 5x will equal 15. And then dividing by 5, and we get x equals 3. And so our solution is 3. Well, let me check, actually. Let's check and absolutely make sure 3 works. If I plug 3 into the original problem, I have 5 times 3 plus 1. We want to know, is that going to equal 4? Well, that's 16 in there, and the square root of 16 is 4. Yes, it does work. So 3 is our solution. Moving on. Solve. Square root of 5x minus 1 plus 3 equals 0. Now, before you square both sides of the equation, you should try to, if possible, you should try to have the radical side, the radical isolated on one side of the equation. In other words, what I should do first here is subtract 3 from both sides. Square root 5x minus 1 equals negative 3. Now the radical is isolated. It's by itself on one side of the equation. That's when you want to square both sides. So square this side and square this side. The square root and the square cancel over here, and that just leaves us with a 5x minus 1. On the right side, if I square negative 3, that's a positive 9. Okay, I've gotten rid of the radical. Move the 1 over. 5x equals 10. Divide by 5 and we get 2. Let's check our result. If I plug 2 into the original equation, I get 5 times 2 minus 1 plus 3. Is that equal to 0? Well, this is the square root of 9 plus 3. Is that 0? No, that's 3 plus 3. That's not equal to 0. No, it didn't work. 2 didn't work here, so I got to rule it out. It's not really a solution. It's called an extraneous solution. Extraneous. So our original equation actually has no solution at all. Or in other words, our solution set is empty. Okay, so this goes to show you always have to check your solutions. And sometimes you can tell, actually, that you're going to have a problem. And I could tell right here is when I was squaring a negative number. If you square a negative number, it's possible your answers will not work. Okay, let's look at another one. Square root x minus 9 minus 3 equals 0. Solve for x. Like I said before you square both sides, you want the radical by itself. So I'm going to move the 3 over to the right side. And that gives me square root x minus 9 equals positive 3. Now I will square both sides. The square root and the square cancel each other out on the left and leaves me with just x minus 9. On the right side we have 9. And x is 18. Let's do a quick check just to make sure. If I plug 18 into the original problem, is the square root of 18 minus 9 minus a 3 equal to 0? Well, it's the square root 9 minus 3. That is 3 minus 3, and that does equal 0, so yes, it works. 18 is indeed our solution. Okay, let's try one now that's a little more involved. Solve square root 4 minus x equals x plus 2. The square root is by itself on one side of the equation, so I'm going to go ahead and square both sides. Let's rewrite it too. Squaring both sides, the entire side like that. You got to have parentheses around it. On the left, the radical and the square cancel each other out and leaves us with 4 minus x. Now on the right side, remember that x minus 2 squared is not x squared plus 2 squared. It means, I'm going to put on the side here for you. Or I'll just write it right here. That right there, that's x plus 2 times x plus 2. That's x squared FOILed out. Will give us x squared plus 4x plus 4. The common error is to square this improperly, so you got to be very careful with this. This is x squared plus 4x plus 4 here. Right there. Okay, I've gotten rid of the radical. Now I have, notice I have a quadratic left. I got an x squared right there. So I'm going to solve this equation by factoring. I'm going to move everything to the right side so that the equation is set equal to 0. Subtract 4 from both sides. Add x to both sides. If I do that, I'll have 0 equals x squared plus 5x. Solve the equation now by factoring. I can factor an x out of the right side. And so as there are possible solutions, x equals 0 or x plus 5 equals 0. And so going up here now, x equals 0 or x equals negative 5. Now remember, we can't trust the solutions. We really got to check and see if they work. So let's check 0. If I plug it into the original problem, is the square root of 4 minus 0, is that equal to 0 plus 2? And that is a yes, that will work. So 0 is a solution, it works. Let's check negative 5. Plugging negative 5 into the original problem, that would be 4 minus a negative 5. Is that going to equal negative 5 plus 2? Is the square root of 9 equal to negative 3? And the answer to that is no, 3 is not equal to negative 3, no. So 5 didn't work. I got to cross it out. Negative 5 doesn't work, it's no good. So the only solution to this equation is 0. our solution set is 0. Let's look at another one very similar to this problem. Solve square root 3x minus 5 equals x minus 1. Okay, the radical is by itself, so I'm going to square both sides. There we go, I squared both sides. On the left side, we'll be left with a 3x minus 5. And on the right side, properly FOILed out, I will get x squared minus 2x plus 1. Remember to FOIL it out squared. Okay, I have a quadratic again, so just like the last problem, I am going to move everything to the right side, combining my like terms, and I should end up with, let's see here, subtract 3x, add 5. I will end up with 0 equals x squared minus 5x plus 6. Factor the right side. The two numbers that multiply to 6 but add up to negative 5 are negative 3 and negative 2. So x minus 3, x minus 2. Now, according to the zero product property, x minus 3 equals 0, or x minus 2 equals 0. So we get 3 or 2 as our possible answers. But let's check. Let's check 3. Plugging 3 into the original, we get 3 times 3 minus 5. Does that equal 3 minus 1? That would be the square root of 9 minus 5 is 4. Square root of 4, is that equal to 2? Yes, it works. 3 works. Let's now check x equals 2 as a possible answer. I'm going to plug 2 into the original equation. Is the square root of 3 times 2 minus 5, is that equal to 2 minus 1? This is the square root of 1, and is that equal to 1? Yes, it works too. So this time, both answers work. They're both solutions, and so my solution set is 2 and 3. 2 solutions to our equation. Very good. Okay, moving on. Solve square root x squared minus 4x plus 9 equals x minus 1. Oh, yeah, that's right. Okay, square both sides, once again. Squaring both sides. On the left side, we'll just have the square root and the square canceling. We're left with this quadratic x squared minus 4x plus 9. On the right side, we'll FOIL this out. We did this one in the last problem. That FOILs out to, double check here, FOIL x squared plus 1 minus 1x minus 1x. X squared minus 2x plus 1. Okay. Now, let's see. The x squareds cancel away. Subtract x squared from both sides, and it's gone. So I got negative 4x plus 9. That equals negative 2x plus 1. Move the 2x to the other side, and I'll have negative 2x plus 9 equals 1. Subtract 9 from both sides. Negative 2x equals negative 8, and so x will be positive 4. Let's quickly check and make sure that it works. You can never trust these answers. Let's see, check. Plug 4 into the original problem. We'll have 4 squared minus 4 times 4 plus 9. Is that equal to 4 minus 1? Well, this simplifies to square root 9. That's just a 9 in there. Is that equal to 3? And that answer is yes, it works. Therefore, the solution to our equation here is 4. Solved. Let's do another one like that. Square root 4x squared plus 2x minus 3, and that equals 2x plus 7. Okay, the radical once again is by itself, so I'm going to square both sides immediately. Square, square. On the left side, the square root and the square cancel away, and that leaves us with 4x squared plus 2x minus 3. On the right side, we've got to FOIL that out. 2x plus 7 times 2x plus 7. 4x squared plus 14x plus 14x plus 49. Add those like terms right there, and we have 4x squared plus 28x plus 49. Okay, I FOILed it out. If I subtract 4x squared from both sides, they disappear. Gone, 0. 2x minus 3 equals 28x plus 49. I will now subtract 28x from both sides, and that gives me negative 26x minus 3 equals 49. Add 3 to both sides, and we get right over here, negative 26x equals 52. Divide, and we get negative 2. Quick check. Let's make sure that it works in the original problem. If I plug negative 2 into the original, I get 4 times negative 2 squared plus 2 times negative 2 minus 3. Is that going to equal 2 times negative 2 plus 7? Excuse me. Well, if we simplify what's under the radical, we should get, let's see, that's a 4 times a 4. That's 16. Minus 4 minus 3 is minus 7. So that's a 9. And is that going to equal negative 4 plus 7? That's 3 equals 3. Yes, it works. So x equals negative 2 works, and so our solution set is just the answer, negative 2. And we've solved our equation. Okay. Let's look now at an equation where we actually have two different radicals. These tend to be the most difficult type simply because they take quite a few steps to solve. Square root 5x plus 6 plus square root 3x plus 4 equals 2. Now, I don't want to square both sides when both radicals are on the same side. So what I got to do is at least move one radical over. So I'm going to write this as the square root of 5x plus 6 equals 2 minus the square root of 3x plus 4. Make sure that you have one radical on one side of the equation and the other radicals on the other side. Now I'm going to square both sides, like that. Squared both sides. The left side, the square root here, and the square cancel each other away, and that leaves you with 5x plus 6. Now on this side, I have to FOIL that out. FOIL. That's 2 minus square root 3x plus 4 times itself. Let's see what we get if we do that. FOIL method. 2 times 2 is 4. Excuse me. 2 times negative radical 3x plus 4, negative 2 square root 3x plus 4. That times that is another negative 2 square root 3x plus 4. And if I multiply square root 3x plus 4 times another square root 3x plus 4, that's just a 3x plus 4. The radicals sort of cancel themselves out, just 3x plus 4. Simplifying a little bit here, I've got a 4 here and a 4 there. That is 8 plus a 3x. And then I can combine these like terms. That's minus 4 radical 3x plus 4. And so finally I've got this side. This is 8 plus 3x minus 4 square root 3x plus 4. Good. Okay, foiling this type of problem, this sort of thing out is for the hardest part of this type of equation. Now notice I did square both sides, but I still have a radical left right there. So what I'm going to have to do now is move everything over except the radical, and I'm going to square both sides again a second time. So in these problems I've got to square both sides 2 times. I'm going to subtract 8 from both sides and subtract 3x from both sides. That will give me 2x minus 2. Oh, wait, hang on a second. That doesn't go there. Okay, we've got 2x minus 2 on the left, and we've got negative 4 square root 3x plus 4 on the right. Okay, so now we're going to, I could actually make these a little smaller by dividing both sides by 2 first. If I divide both sides by 2, then this becomes x minus 1, and this side is negative 2 square root 3x plus 4. Okay, now I am ready to square both sides one more time. I'm going to square this side, and I'm going to square this side. I'm putting my answer up here now. If I square x minus 1, I get x squared minus 2x plus 1. I FOILed it out. On the right side, I have to square the negative 2, which is a 4. And if I square this radical, the radical sign disappears, and I have 3x plus 4. Okay, so that's what we get. Notice all the radicals are now gone, at least. X squared minus 2x plus 1 equals 12x plus 16. I have a quadratic here, so I'm going to move everything to the left side, setting the right side equal to 0. That'll give me x squared minus 14x minus 15 equals 0. Factor the left side, and we've got x minus 15x plus 1 is our factorization. And so this tells me that x will equal 15, or here, this one will be x equals negative 1. Okay, so a lot of work to solve this sort of problem. Now, I'm out of room to check, but if you do check these answers, it turns out that 15 is not going to work. If you tried in the original problem, 15 is no good. So we're going to rule that out. If you check on your own, you'll find that plugging negative 1 in will work in the original equation. So our one answer to this is -1. -1 is the solution to our equation. Okay, a lot involved in solving one of these. Let's try one more like this. Move way over to the left here. Square root x plus 1 minus square root x minus 4 equals 1. Okay, remember the first step on these. If you have two radicals, move one of them to the other side. Square root x plus 1 equals 1 plus square root x minus 4. Now we square both sides. Square this side and square this side. On the left, we just have x plus 1. And that's the easy part. Right here, we have to FOIL it out. And that will be 1. Okay, let's do it on the side again, just to be sure. Squaring it and multiplying it to itself. FOILing it out. 1 times 1 is 1. 1 times square root x minus 4 is 1 square root x minus 4. I've got another 1 times square root x minus 4. And then finally, a square root x minus 4 times a square root x minus 4 is just an x minus 4. The radical disappears. And so we got this. This simplifies to, let's see, 1 and -4 and x. That's going to be x minus 3. And then I got 2 of those radicals, so that's 2 square root x minus 4s. That's what it FOILs out to. So let's write it over here. X minus 3 plus 2 square root x minus 4. Okay, we have a radical left in the equation right here. So I need to move everything else to the other side. If I subtract x, x's are gone. I'm going to add 3 to both sides. And I will get 4 equals 2 square root x minus 4. So it works down to that. I can divide both sides by 2. And I end up with 2 equals square root x minus 4. And now I'm ready to square both sides one more time. So I'll write it up here now. Square both sides again. And that will give us 4 equals x minus 4. And so x is 8 is our possible answer. Let's check and make sure that 8 works. If I plug 8 into the original problem, I've got this. The square root of 8 plus 1 minus the square root of 8 minus 4. Does that equal 1 is our question. Well, this is the square root of 9. This is the square root of 4. That's a 3 minus 2, and that does equal 1. Yes, it works. So 8 is our answer. So our solution set contains 8 as our answer. And we've solved it. All the equations that we've solved so far involve square roots, but you could have other roots such as cube roots and fourth roots as well. Let's do an example of those. Cube root of x plus 5 equals the cube root of 2x minus 6. To get rid of a cube root, you do not square both sides of the equation. You must cube both sides of the equation. Cube both sides. Like this. Cubed and cubed. The cube root and the cube cancel each other out. And so this will just be x plus 5 over here. On the right side, the cube root and the cube cancel each other out and leaves us with 2x minus 6. And now I can simplify. Subtracting x from both sides, I get 5 equals x minus 6, and x equals 11. If we do check this in the original problem, it will work. And so we get 11 as our solution. And that's our lesson on solving radical equations.